Swayam Prabha. Digital India. Educated India.
Okay, dear students, let's show you in this tutorial some new and advanced some problem. Based on this problem, you can correlate the whole story that I taught during my whole courses. So today's tutorial mainly for the various electrochemical sensors that can help you, can guide you to understand all the problems you can face during the development of biosensors. This is mainly, see, this course is very much related to your practical applications, your independent thinking. That's why I plan in this tutorial, let's discuss some commercializations of the biosensors and the biodevices. How we can commercialize of a biosensor and biodevices and kind of problem you may face during the commercializations process. Clear? See, I just taught the development of biosensor during the whole class. Suppose you got some idea and you wrote your project, and then you have to start your work, and based on your result and your development, if you want to start your own startup, right, if you want to commercialize that technology, you want to bring that technology near patient immediately, you want to bring that technology in the market. So how you can commercialize? So I'm just going to tell you very briefly some points that you should keep in mind before the commercializations of your biosensor or any biodevices. This is not only applicable for this is very general thing. This is equally applicable for any technology transfer. So mainly it is technology transfer. So you have one device, right? So please try to remember the points. So first point, you have to plan, like which area you want to develop a new device. But this plan should be very much innovative, that I already taught you during the writing of the proposal. So there should have a research gap, right? Based on this research gap, your plan should be innovative. So when you are going to commercialize, so your innovative idea should not be leaked. Means it is better don't discuss your whole innovation in your plan publicly. Even generally it is recommended, don't bring your new concept in the confines or somewhere before coming to the market. So it is everything your own copyright kind of things. So with whom then you can discuss? You should not discuss all the plan, rather with your collaborators or with some others, like suppose you are developing a device, so you should discuss with your collaborator or with some like some medical doctors and other engineers. You should discuss the possibility. Possibility means how we can solve the your innovations, your research gap, how we can solve that. You can discuss with them, then try to summarize the whole idea and how we can solve those problems. You should not openly discuss. Okay, before then only you can make the patent. So if you want to make the patent, so your idea should not be openly discussed to others. Someone else should not be, someone else should not involved for this work. If it is your own copyright, means try to keep inside your group, but in your research, and try to complete this work and file the patent. So, in every institute they have the IP section, means that property, that is your intelligent property, that they can protect. Or if you don't have, maybe you have to approach to the proper sections and you have to file your work and ask them to copyright. You have to copyright your innovations. Then what you will do? Then after the patent filing, and once it is done, then you have to think about how you can bring these innovations. Then you have to contact to the industry or someone that they can help you. And there's definitely there should be some sharing of your like your profit. So the industry people, they can help you, like some fabrications of your sensors. They may check like the reproducibility of the sensor, because it is really reproducible or not. Then only they will bring this innovation in the market. So your innovation should not be only inside the laboratory based, right? So as we are going to use this one for commercialization purpose, so it should be very much reproducible. Means it is directly related to the reliability of your sensor. Reliability. Without this reliability, you cannot commercialize, because your sensor may be stored for the very long time outside the environment, and if it not show the reproducible data, then you cannot bring this device, especially this kind of device for the solutions of this current problem. So you will think about the reproducibility always. Okay, so this is the things that I am going to tell you when you are thinking for the commercialization of the device of your sensor. First, just try to think about the innovation technique, should not openly discussed, and make it like your own copyright, your patent, and then approach slowly to the industry, and then try to make your product and bring to the market. Second thing, second topic today's tutorial I want to discuss, that is the wash-free technique, how we can bring for the point of care. That I already taught you, but finally, as we are end of this course, so let's think how we can bring this all the innovations or whatever you learn to the market, right? So wash-free is the best method, because you don't need many step washing basically. Washing not required, right? If you don't need the washing, then it will be useful for handling by end user, because end user, what they will do, they will just drop their sample, like the glucometer available in the market, right? Just they will you have the chip, here there is a, you can drop the sample, here you can drop on drop of the blood, then this one you can inject with a potentiostat, right? There is electronic part, and you will see the electronic, your digital value on skin, something like this. So this kind of innovations is very important for commercializations. Okay, so in this case, in this kind of cases, it is, you can see this, they are wash free. Why we need washing, you know already, to wash out all the interference species, to wash out, that is, you don't need, or they can increase the background current, you have to remove them. For that you only washing. But if you can develop some washing free technology, that I taught many washing free technology, right? Can you remember? One is the proximity dependent wash free, right? What is this proximity dependent wash free? I just summarizing you again, like if you have your surface a target, and if you don't have a surface a target, if you have surface a target, then your secondary antibody will bind, and it will have a label, right? And this label, a substrate can react, it can form product, and this product can react very close to the surface, it will transfer the electron. When you can incorporate in this surface a redox cycling reaction, right? you can incorporate a redox cycling reaction. So, if this redox cycling reaction is very close to the surface, then your electron transfer rate will be much faster because of the very closer to the surface. That is called the proximity dependent wasp free, means you are just dropping your all the reagent on the sensor surface, and because of the close proximity you will get the faster electron transfer. So, this is the very fast process. So, you will get the higher current. And if you do not have target, then your level everything, your all the reagent everything will be very far from the surface. So, because of the far, so your reaction rate will be slow, right. So, this is the wasp free concept you can apply for a device development, and this I taught already, right. And second wasp free technique you can, I think, should remember, that is the reagent free, and they can change the conformation. So, in this case, wasp free proximity case, they are not changing the conformation, but suppose you have a DNA or aptamer, it will have some tag, electroactive tag, right. So, if it bind with some target, then it will change its conformations and it will come to the close to the surface, right, that I taught you. So, this is also kind of wasp free concept. You do not need washing, and also we do not need many reagents also. That is why it is reagent free or at the same time wasp free. This kind of concept you can apply for the commercializations of your technology. Try to focus more in this kind of technology if you want to bring something. But it should be very simple. That is the main concept. Why? And that is the explanation, like you can compare with the glucometer. Just drop, wait for few seconds and see the data. People want something like this device, but if this is included washing steps, then only expert persons or in the diagnostic center they can do. Layman, no, not possible. Okay, so that is why if you really want commercialization, think about this kind of washing free technology. So, I taught you like proximity dependent, reagent free, and number 3 is the lateral flow. Number 3 is the lateral flow assay. I think you can just try to remember lateral flow case. Also, it is kind of wasp free. Some pregnancy test kit kind of things already available in the market. So, they are the kind of lateral flow or wasp free technology. They are also same thing, just drop the urine sample and you will see the color. One is the control and another is the so first line is the test line, second line is the control. So, test and control you can see this color change, or I already taught in my course, that is the electrochemical change. So, here in the right, if you have like a paper strip, here you are dropping the sample, maybe. So, here you can working, counter, reference, you can fabricate, okay, and accordingly means if it is your like working electrode, and here all of your reagent will be immobilized, and I mean if you have the target and secondary antibody, they will bind here, and you can add these things with a potentiostat, and you can measure the very small number of change, like target you can get, you may get the signal right here. So, this lateral flow basically, see, this is because of the capillary flow of this paper, it has this property. If you drop it, flow through this, and here the discal region, means here all the excess things will be stored. So, you get your target, when your whatever you want, like in the working electrode case, you wanted to see maybe color change or maybe signal, electrochemical signal change, whatever. In pregnancy test kit kind of thing, you may see the color change. And if you want the electrochemical signal change, then you have to design like working counter difference electrode fabrication, you have to do that. I already taught you, so that you can predict, right. Just I am guiding you today, like how you can predict, how you can think some new innovation for the commercialization. So, this kind of technology is very much important if you want to think about the commercializations, okay. So lateral flow case, I just want to discuss little more. Why? Because it is very much useful nowadays, in the COVID time also. So people develop so many lateral flow based like rapid test kit. So this kind of test kit is really important. Suppose like a paper strip. Here you can make like see some like multiplex detections. So I will recommend let's go the multiplex detection instead of a single detections. Why? Because based on the multiple analyte detections, you can easily predict, when doctor can easily prescribe some medicines. Otherwise, based on only single detection, it can sometimes misguide. Suppose like a fever case, I told you, no, fever. So it is due to what? It can be virus, it can be bacteria, right? That's I told you. If you can develop some multiplex chip, one is the virus case, one is the bacteria. So if it is virus related, then doctor will not prescribe the antibiotic. So if it is bacteria related, then doctor say okay, it is not related to the virus, so you can go for some antibiotic, something like this. So development of multiplex system and wash-free technology is really important for the commercialization. So this kind of scope you can think, and definitely just try to think that very simple steps, simple technology, not many steps. If you have any solution, think about the simple, let's drop and sense kind of thing. This is the one of summary for this course. And yes, now let's come back to this lateral flow again. So you can design like test 1, test 2 and some control. So why we need control? I already told you that if your strip is working fine or not. Suppose see here, this is the sample pad here. So you add some sample, and here you will have all the basic reagent that you need for the detections. Then your all the reagent will dissolve, and if target one comes, then you will get that target will bind with this. Suppose you have the antibody, this target will bind, and secondary antibody if you have here, that also will bind, and it will show the color here. But if you don't have this target, then it will not bind, it will not show color. But if you don't have target, still your secondary antibody, they should come in the control region and they should bind, and this level mainly we are adding the gold nanoparticles. It is a pink color, and it will means come together, it will show some pink or reddish color, you will see. So if they are really okay, means they are not denatured, they are somehow not damaged, then definitely it will come and bind here and it will show the color. See, suppose if you don't have control line, so your secondary antibody that conjugated with gold, it is not binding T1, it is not binding with T2, and you may think that you don't have the target, means your means negative result. But if some of your secondary antibody is damaged, denatured, not working properly, although you have target, but it is denatured, so it will not bind with the T1 or T2. But if you have control line, it will guide you, right? If it denatured, then control line also will not show the color, so it means your strip is not working. So based on this, you can confidently tell that yes, you are getting false positive or false negative, that you can tell some. It means if you are getting, generally you are saying the negative result, no, it can be the false negative. That false negative data you can definitely say based on the control, this C control data, right? That's why we need this control line. Okay, so just try to think to design this kind of lateral flow assay also, wash-free technology lateral flow assay. Okay, so in the exam, now let's come during the exam time, I may ask this kind of the questions like design a wash-free biosensor and try to use this kind of wash-free technology for commercializations. So, maybe in this NPTEL course the exam may be MCQ type, but this kind of descriptive type also you should prepare so that you can readily answer it. Not only I will recommend means not only you should not write like the whole story very precisely, you can summarize the story like this way I am just telling you. Okay, and next questions, today's tutorial is the nanomaterials for diagnosis. See, my whole course I taught you the different nanomaterials, right? So now if I ask you to summarize the nanomaterials that you have learned in this course, what is the utility, what is the benefit of the nanomaterials, why we need the nanomaterial? Now if I ask you in the end of this course, what is the answer? So I can summarize 1, 2, 3, 4 way. The first thing is that nanomaterial, so suppose you have a surface, right? This is the transducer surface. So you may want to increase the electron transfer rate. In this case, you can use some nanoparticle, right? So nanoparticle like gold nanoparticle, something like this. So they can enhance the electron transfer rate. And second thing, they can, so one is the conductivity. Conductivity you may improve. Another is the surface area. So you may ask why we need to improve the surface area. It is very much needed because calibration plot you are getting. I just taught you all the measurement of the calibration plot from the low concentration to high concentration, right? You are getting the calibration plot. So here is the concentration of your target and here is the output signal. Output signal. So if you can detect a very large range of the concentrations, then your sensor surface will be very much applicable to detect very low limit to very high limit of detections. Why we need the sometimes very high limit of detections? Because in some disease cases the target level can be very high, and suppose some cancer like prostate specific antigen, this cancer biomarker, it can be sometimes maybe microgram per ml, but your sensor maybe can detect the nanogram per ml and it can stop working. So if some patient has the very microgram per ml, so your sensor can detect only nanogram. So you may think that this patient may contain only nanogram, but no, it's contain very high. So we have to take some first precaution. That's why your sensor should have the very broad detection limit. How you can improve this broad detection limit? That nanomaterial can help. Okay, so why I am reminding you again at the end of this class? Because then only while you are planning some proposal, then at the very beginning you have to think these all the major criteria for the development of the sensor. So you should mainly try to think to make a broad range of the sensor. So suppose if it's a planar surface and you are immobilizing your antibody, right? So how many antibody you are immobilizing? Just think. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you have the 10 antibody, right? But now if you immobilize your same sensor surface with some nanomaterial, so it is something like this. See, your why I am saying the surface area increase? Because actually it is the, if you measure like the radius of this surface, it is the same, because planar surface area is the same, but actual surface area, actual your active surface area for the sensing. See, this is the, what is the actual active surface area? Is this one. See, so okay, so this is the your actual active surface area. See, it is far better and very much higher than this one. Okay, so here you can immunize antibody. See how many antibody you can impolize here, here, again here. See. So if here you immunize 10, here maybe here, maybe you can improve more than 100. So you may improve the 10 times, sometimes 100 times you can improve the number of the bioreceptors you can immobilize. So if more bioreceptors, see now this sensor surface can be easily saturated, right? Saturation may come very fast, but in this case the saturation may not come very fast, because if you increase the target concentration, so nanogram to micro, micro to like it can attract the analytes, right? That's why you may go like from nano to micro also, microgram per ml. That's why nanomaterial can help these things. And another things that I think I already taught you in this class, that is the functionalization, right? Functionalization is also very much important. Easily, if you have some nanomaterial surface, you can functionalize the surface, like I say carbon based, or preferable material is the carbon based nanomaterial, right? Carbon based nanomaterial, they have many functional group. You can easily functionalize carboxylic group, right? So if you have the carboxylic group on the surface and your biological stuff has the amine group, and what you will do then, so biological stuff it has the amine, and carboxylamine, the amide bond you can form with the help of EDC NHS, right? And easily your surface can be covered with some biological molecule. That can nanomaterial can help. Also you can easily tune the tuning property that I taught you. You can easily tune the surface catalytic activity with the nanomaterial. The tuning can be done easily, right? So for the all the things, that's why you need some nanomaterial for the diagnosis. It has so many other properties also. Main things I just summarize before end of this course, so that while you are making some plan, just try to remember this kind of all the story for the nanomaterial, so that easily you can bring those concept and you can make a novel idea. Okay, so what is the conclusions of this tutorial? So I taught you mainly, just try to remember to make some very good technology that can easily transferable, or you can bring easily to the market. So I can say whenever you will focus some research, this research should not be only in the lab. You should bring this one to bench to bedside applications. Right. So bench to bedside application is very important. Mainly point of care testing device only can bring your technology to the market easily. And for all the commercialization, that I taught you how to make your patent and how to you can bring the technology in the market, that I just mentioned you in this lecture. Then second things I taught, just try to make some wash-free device, not the washing base. So wash-free device can help easily, so the layman can use easily, just drop and sense kind of technology. And number 3 is the nanomaterial. Nanomaterial is the very important for the biosensor development. It has huge like properties you can use, like surface. The very basic property is the conductivity, surface area. You can tune easily. Those are the things. But it has so many other, like the functionalization, so many other also properties you can use for the sensing development. Okay, so this tutorial helps you to summarize maximum the concept I taught. The next class I will summarize, and I will briefly cover all the courses next slide, and then I will try to complete this course. Thank you students.